Today we are going to see all type of pointers which we are going to use in C program and even embedded C. So the pointer is very important topic. So because in embedded systems we have to directly access the memory or register. So for accessing that, we need a pointers to store that memories or any values, so anything related to that. So pointers we have to use that in different purpose, and everything have a different uh, use cases and plus points and the positive points and negative points kind of things. So when we come to the program, we have a STDIO and another library we have to add for STD library. What we are going to do is that using pointer, first we are going to see what is pointer, how to use the pointer. Then we have to going to allocate and reallocating the memory using pointer, how to allocate and going to free the memory to the specific section, and going to see what is double pointer and what is void pointer. So these are our sections. So first we have a one function, so like a simple thing, we have declared one uh, function which will print number. Normally it is printing the number. Then we have a int main. Here we have declared int x equal to 10, which means that we declared one variable as a 10. Then we are declaring integer ptr as a pointer. So this is the asterisk which is meant to be as a pointer. So this is the pointer. Whenever this symbol will come, this is act as a pointer. So pointer ptr equal to address of x. So this ptr, if we declare that as a pointer, this thing, the ptr will hold the address of x, which means whatever the x, x will have a some x. Let's say that 0x0095. So this is the address of x. So this address will be stored into pointer. So this is the definition of this line. So this ptr is holding the address of x, which means that 0x0098. So this is what is holding. If you use pointer, then that pointer of ptr is holding the value of address. So let's say 0x0010 is the address of x. Now ptr holding the same address 0x0010, then pointer ptr holding the value of x, value of the address, the specific address. So whatever we are storing the address, so if you use pointer to the variable and the specific variable, then it will take the value from it. So that's what we are printing, value of x using pointer. So if we do that star ptr, then it will print the value of pointer. Then next what we are going to do is that again we are declaring int n equal to 5. Then again we are declaring int pointer of array. Then we have to allocate the memory for that specific array. For that we need to do the type of the value. Then we have to use the pointer. So this is the pointer where we are going to allocate the memory. Then the malloc. So this is the inbuilt library, that's why we are using std so that's why we are using the malloc. Then n, int size of integer. So n means this is 5, then size of integer. So, as you know, size of integer, it is holding 4 bytes. So what this line will do is that we are allocating integer pointer, we are allocating memory for integer pointer. Then this is the size of that memory. So what it will do is that n the time of size. So size of integer is 4 and n is 5, which means that 5 into 4. So it will allocate the memory. Let's say that it is thing from 0000, and 5 into 4 means it's direct of 20. So the total memory it will hold is that 0020. So that array of pointer will hold this line will create a 20 byte array. So this is the meaning of that. Then every time if you allocate the memory, you have to check whether that memory is allocated correctly or not. So for that you have to use if array is null or not. Then if it is null, then the memory is not allocated correctly, then you have to return it fully. Then we are directly printing that array. So whatever we are initializing, we are printing that array. For printing, we are using the normal for loop. Then every storage, every index we are storing, incrementing that I plus 1, I plus 2, I plus 3 kind of thing. Then it will print that array. Then again, let's say that we already have an array. So first time when we run the code first time, we need that array size as a 5. Then again we have to increase the array size. So it's kind of it's called as a dynamic memory allocation. So when it comes to embedded system, the memory will be very low. So every time you can't use the full memory. Let's say that yeah, some microcontrollers or microprocessor comes with the 1 MB, 2 MB heap memory or stack memory, it will come. So this whatever the memory you are using, so that will be directly stored in the heap memory. So all the global variables, local variables will be stored in the stack memory. So heap memory will consist of low memory bytes. So to use that or to accessing that memory, you have to reallocate or free that memory. Then only the memory space will be given to other memory things which the embedded system can easily access that. So in that case, we have to use the malloc and realloc are free. So then only we can use the memory more wisely, because sometimes we don't need a memory fully. That time that free memory can used by any other memory. That's why the memory allocation is very needed. That free memory will give the controller to work fast, or easy memory allocation will not take too much time to allocate the thing. uh, so it won't go to the overflow also. That's why we need a malloc and relock. So first in our system we need a 5 index, so we only need a 5 byte arrays. Then again we need the same array and the 10 index. So for that we already allocated a memory, but we need to reallocate it. So already 5 memory is allocated. So if you reallocate it, which means same integer pointer, then we are going to reallocating it. In that time, which memory, which variable you are going to reallocate, so that you have to mention, then comma the same n into size. So now if you do the reallocation, what it will do is that it is already allocated. So 00202, then whatever the size it is going to same 5. 10 means, so it will start from 00, then the total memory will start to hold. So total memory is allocated. Finally it is allocated things. So it will not delete whatever already the 5 memory is holding. So 002 020 holding that already 5 data, so it will not delete that. So again we are going to check the memory allocation, whether it is allocated or not. Then again we are printing that thing. So in this time we are not overwriting it, we are starting from 5. So from 5 it will write to the total number, then it will print. So these are the things. So these are the allocating and reallocating. Then we are freeing that array. So after using that all the arrays, all the functions, we are freeing that array. So that time all the array, which means the 10 bytes arrays, will be cleaned fully. That memory can be used by any other variables or any other memory allocation. So that's how this will work. Then so until that we will see the output. So this is the output. So from first we come, this is the first printf. So what this printf is printing is that 10. As you can see, it is printing 10 because the value which is stored in x is 10. Then it is printing array, every array where this, because memory is allocated correctly, so that's why it's not coming. Then we are printing one by one. So as you can see, we are we allocated that and we are printing. So here when you create it, you have to for allocating memory you have to use the pointer, but you are now directly accessing the value. So whatever it is, the here the value will be stored in the variable called array. So when you creating that, when you allocating that, you have to use the pointer. So normally if you want to print that, or if you want to access it, or in the any other variable, you can directly access the variable, not to use the pointer. Here it is accessing it, and one by one it is printing 1 2 3 4 5. Then after allocating it, as you can see, it is printing full values. So this is the thing, and next what we are going to see is that the next thing is the double pointer. So what pointer will do is that pointer will point to the address of the variable. Then what double pointer will do that is that it will point to the pointer. So that's the difference between pointer and a double pointer. So pointer is pointing to the variable address, and the double pointer is pointing to the pointer. So now first what we are doing is that we declare a one double pointer 1 as a double pointer, and we are allocating that for that, because now what we are going to do is that we are going to allocate the memory for double pointer, integer double pointer, using malloc. So the normal malloc will work. Now normally first time we don't know the size of that thing, so that's why we are simply using the size of integer pointer. Now next we are declaring the normal pointer. So it will same as that pointer is there, right? So that will store that thing. Then we are going to print the double pointer 1. So first time it will not holding any data, because it is we are simply declaring that, and we are allocating the memory. Then we are directly printing that with the percentage d with the double pointer 1. As you can see, it is printing some junk values. Then what we are doing is that directly don't need to use the double pointer, because we know that it is pointing to the pointer. This double pointer is going to pointing to the pointer. So this time we can only have to use the pointer, double pointer. So that pointer is going to point to the double pointer. So if it is a normal variable, you have to use the address, but a double ptr is a pointer, so you don't need to use the address. If you want to store the address of x, which means the x is not a pointer, it's a normal variable, then you have to use the address. Already the double pointer is holding one address, so that's why you don't need to use the address. So it will directly store the address of double pointer. So again, if you print the double pointer with the same percentage d, so you will see the value, though the x value. Before that we see that x value is 10, right? So that you can see. So as you can see, this double pointer, double ptr pointer is holding the address of x, so it will only hold the address, it will not hold the value of x. So that's the difference between double pointer and pointer. And again, if you print that, so here if you are printing that, uh, now junk will come again, you are going to do the double pointer, you are storing that to normal pointer which is addressing that. So that is printed. Then what you are going to do is that you are going to print the address of the normal pointer. So as you can see, this is the first pointer, sorry, that pointer one's address. So this is the pointer one's address, and again what you are doing is that you are printing the double pointer. So the same thing 10 is coming, which means that to this double point ptr and double ptr1 both are holding the same address. But sometimes what you have to do is that without assigning you can use that in multiple places, where directly using the this pointer, you can use this pointer, double ptr1. So only you can use this ptr to assign or change the values. So whenever you want to change accessing, let's say that this double ptr is only used to assign the variables. So this double ptr1 is used to manipulate variables or taking the values from outside of the scope kind of things that you can. So for two different application, so you can use that, like for a local variable or some kind of one operation, you can use specific pointer, and another option you can use the different pointer with a different name. So that's for readability and writability, you can use that for that. So again, you are going to print the address of the normal WPTI. So as you can see, both are different address, which means that this pointer address is different, this pointer address is different. So you can use the both address to hold that value. So two variables having holding the same address of the value. So that's the use of a double pointer. Then what we are going to do is that we are freeing that both the pointers. Then that is done. So that's the use of double pointer. Then again what we are going to use is that void pointer. So the void pointer is that it will not point to any specific data type. So in any time you can change the data type of that specific pointer. So as you can see, before that, whenever we are declaring that, we have to declare any some kind of data type. So in pointer you can use the different data type with the same variable. It's kind of reusability of the same pointer, no need to reusability of same address. So when you say that you declare a one pointer, so it is stored, it have a one specific address. So if you are holding the same address, if it will use the same data type. So if you use a void pointer, it don't specific to any data type. In runtime you can change the data type, so no need to change the address. So again and again you don't need to use the different variable data type for a different pointer to that kind of thing. So it used to reduce the um, memory says or programming or coding lines. So as you can see void, so we have declared one void pointer, and again we have declared integer number. Now what you are going to do is that void pointer address of number. So it is printing, so that void pointer holding the integer value, integer data type and number variable, then you are printing that. So here you have to declare that what pointer you are going to do that. Then again we do that thing. So float n I equal to 3.14. Again you do the same thing. So rather than number, you are going to use I. Then here when you print, you have to change that float. So this is the data type of that void pointer. So if you print that, so here we have to change that to float. So if you print that, so it is printing 3.14 as you can see. Then the first printer it is going to use things. So using the same pointer you can change the data types of the. So that's why the void pointer is needed. So using the different data type, you can use the same pointer name with the same pointer address. Then what we are going to do is that we are going to use the function pointer. So for that you have to use basic void, and you have to declare that as a function pointer. This is the function pointer name, and this is pointer, and which type you are going to hold that thing. So this is the function pointer name, and this function ptr pointer holding the address of print number. So the print number what we have seen is that here we have declared one print number function. So whenever you want to use that print number, you can use the function pointer 25. So what it will do is that it will pointing to that specific function. Then whenever you want to do that, you can call that function. So this is the use of function pointer. So nothing, as you can see, so function pointer means it is storing to print at no, print number, then it will send the 25. So here you have to open bracket. So what type of data you have to send. It's like a function declaration. You have to do that when you're declaring the function pointer. So that's the difference between that. So that's the use case of pointer. Specifically, it is used for to do the reusability of the same address and the same function kind of thing. So this is the basic thing. And if you want to use that for another, if you write that rather than that print number, we are again writing the different number one. So this is also this is doing some other kind of different work. So if you want to do that again, let's say that it need a two integers. So here I am printing two integers. That is a different thing because again we have to declare that as a different pointer. So we declare that again. What we are doing is that we are so again what we are doing is that we have written a different function print number one. Again that pointer is now holding that print number. Again if you call this function pointer in n number of time, it will only calling that function name. So again I'm changing it. As you can see, only number one is doing. Again if you want to go with that first function, then you can again holding that, again you can call that function. So as you can see, the function is changing, continuously changing. So this is the function pointer. So these are the in depth, there is a lot of functionalities in pointer, but this is the basic use of pointer.